Welcome to 8 Series Training Modules 8SP-121, 859 Motor Relay. In this training module, we're going to cover these topics: the hardware, the software configuration, thermal model, unbalance element 46 and 47, overcurrent elements of the motor, undercurrent and underpower 37 and 37P, loss of excitation and reactive power 40 and 40Q, acceleration time and start supervision, speed 12 and 14 and backspin detection, RTD temperature and RTD trouble. And finally, we're going to recap what we learned in this training module. Now, let's get started. 859 is the latest product of 8 Series family of products after 850 feeder relay, 869 motor relay, 845 transformer relay, and 889 generator relay. 859 motor relay is the fifth IED of the 8 Series products. 859 has the same dimension as Multilin 369, 269, 269 Plus, and 169, although the front faceplate size are slightly different, but the panel cutout size are all the same. That's 10.45 by 6.85 inch or 265.4 mm by 174 mm. 859 is made not only to replace the installed Multilin 169 to 369 relays, but also can be used for the new installations with shallow depth cabinet. With a depth of 3.5 or 89 mm, the 859 is ideal for the MCC with shallow depths. Also, the detachable display can be mounted up to 15 feet or 5 meters away from the device with shielded network cable. No separate source of control power is required for the display module. This feature allows the greater installation flexibility for the space constraints. The relay will still function and protect the motor without the display connected. 859 can be considered the next generation of the Multilin 369 on the 8 Series platform. It inherited all the quality and reliability features of the 8 Series, such like the IPC 610 Class 3 manufacturing, 100% board-level ESS testing, environmental stress screening, and standard harsh environmental coating, etc. For the other performance features, please refer to the 8 Series 100 overview video. 859 also inherited the advanced motor monitoring features from the 869 relay, such as ESA, electrical signature analysis, broken rotor bar, and stator interturn, etc. 859 faceplate is the same as all the other 8 Series relays. It has a big LCD display of graphic control panel. The single line diagram and the parameters are also shown in this screen. There are 5 navigation push buttons, can navigate the menu according to the menu tab associated with the push buttons. Below the soft menu navigation key, there are 14 LEDs, 11 of them are programmable. There are 3 programmable push buttons and LEDs below. On the right side, the navigation keys, including the arrow keys, escape keys, enter keys, help keys, and reset keys. The reset keys is used to reset a trip or latched alarm. Below these keys, there's one USB port for the quick connection with the Vista software. Now I'm going to demo how to navigate the 859 front panel menu screen to check the order code, metering, status, set points, event recorder, and target message, etc. And this demo is done with the 8 Series and Vista software. It has the same effect as push the buttons on the front panel. I can either using the mouse click to press the button, or I can press the front panel of the relay and you can see updated screen display in the software. So as we know that in the 369, the main hierarchy menu structure is actual value and the set points. In the 8 Series, there are 5 menu tab associated with the navigation push buttons are the targets, status, metering, set points, and records. So now if I want to check the order code, I can click this status. So I'm going to click from the front panel and then click info button, info, and from here I can see the order code is 859 and then the serial number of the relay, and we can also know the firmware information. And if you click this down arrow key button, you can see more information like MAC address, etc. So now we can go back and check the other status. We can check the status of the contact inputs, the relays, the breaker status. So you can just using this down arrow key to highlight and to check the each one status. So for example, if I want to check the contact inputs, I just click the down arrow key until the contact inputs is highlighted, then press the enter key. Then from the software, we can see this updated the contact inputs, that the contact inputs 1 to 6 status is off. So we can escape from this one and check all the other status information. Then we can further escape and to the main menu. For under the metering, we can check the metered. Actually, we already see some metering value here, but from here we can see more metering under the CT and VT. So this is for the three-phase current and voltage. And we also have one summary to check the vector. So click the summary, click the phasors. We can see that the vectors of the three-phase voltage and phase angle, and also the current. This is the current is 30 degrees lagging the voltage. So that's for the status and the metering, and we can also check the target information. If any element operated, we can click the button, and this is no target operated for this one, and we can check the set points. That's all the set points for example, the system, inputs, outputs, and the protection. We just using the arrow key, or we can press this arrow key on the tab key to navigate. It's two-way. You can press this arrow key down, it will highlight, or we can press this one to just to go to the next. We come to the protection, and from here you can see all the protection elements. Okay, so that's for the set points. We can check all the set points of the relay. So compare with the 369, there are only two main menu branches in the 369's actual value, which is a combined status and metering. Another is the set points. And in the 859, if you want to check the records, you can click here and you can see the events of the records, what been operated, and this is the records of each element operated with the timestamp. Okay, so that's the conclusion of this front panel navigation of the 859 by using the 8 series and Vista software. On the rear side of the relay, the terminal mapping and replacement is exactly the same as the 369. On top are the terminals of the 4 output relays: trip, alarm, auxiliary 1 and 2. They are all Form C relays, which means they can both have normally open and normally closed contacts. They all can be programmed as fail-safe or non-fail-safe relays. The control power input is also on the top terminals. The input range is 110 to 250 voltage DC or 100 to 240 V voltage AC. On the left side, the 4 terminals blocks are for 12 RTD inputs. RTD should be 3 wire type 100 ohm platinum, or the nickel, or the 10 ohms copper. The right side terminals are for the 6 digital inputs, 3 RS485 ports, and 4 analog outputs. These green terminal blocks are the same as multi-lean 369, and can be replaced with a terminal of the 369. There are two RJ45 Ethernet ports in the middle lower part of the relay. At the bottom, there are the inputs of the CT, VT, ground CT, as well as the backspin detection of the hi-hat application. The order code of 859 is simplified into the basic 369, or the advanced 869, two applications with the suffix B and A after the 859. So when selected 859B basic, this automatically default all the options to the basic, which are equivalent to the fully loaded 369 relays. When the selection is set to the A advanced 869, this allows users the options to add advanced features like what we have in the 869, such as motor ESA or advanced cybersecurity options.
Hi folks, Paul Phillips here with GE Learning and Development. In this video, we're going to show you how easy it is to do a retrofit from a GE to a GE product. Whether you're going from a 169, 269, 269 Plus, or a 369 to our new 859, this process has been purposely designed to be a one-to-one replacement. As such, the multi-lane 859 has the same rack cutout and depth as existing 169, 269, 269 Plus, and 369 protection relays, so there's no need for complex wiring, drawing changes, or door modifications. Upgrading to the 859 can be accomplished by following a few easy steps that we'll walk you through in this video. First, we'll update the settings file using our Innovista 8 Series software. Second, when upgrading a 369 to an 859, there's no need to disconnect RTD wiring, digital inputs, and communication ports on your 369. Only the terminal blocks will require removal. For the relay outputs and CT-VT inputs of the 369, 269, and 269 Plus, these wires will need to be removed. Third, once step 2 is completed, we can now mount the new 859 protection relay in our rack, plug in the RTD and digital input and communication port terminals of the 369 into the 859 relay, and reconnect the relay's outputs and CT-VT wires. If you're upgrading from a 269 or a 269 Plus, it'll be necessary to remove and reinstall all the wires to complete the upgrade. So now that we've outlined how this upgrade is going to work, let's move over to our rack so our instructor can walk you through the process step by step.
Now we have one 369 relay on the mounting rack. We're going to replace this with one 859 relay. There will be 3 steps. The first one is to do the setting file conversion from 369 into 859. This can be done automatically in the 8 Series and Vista software. For the setting files of the 269 Plus, you need to manually convert them into 859. So now let's power down this relay and remove the wiring from the back. To remove the wiring from the 369, we need to remove the top wiring for the relay outputs and the bottom CT-VT inputs, and then unplug the terminal blocks for the RTDs. For these terminal blocks, we can just unplug them without rewiring the wire on the terminals. And on the left side, we have this digital inputs and the communication ports. So this can be just directly unplugged, and later we can plug into the 859. And now for the CT-VT inputs at bottom, we can just use a screwdriver to manually remove the screws. So now we moved the top and the bottom wiring and unplug the terminal blocks on the right. We're going to remove these mounting screws on the panel. Now the 4 mounting screws are removed. We can gently remove these 369 relays from the rack and replace this with one 859 new relay. So this is the one 859 we're going to put in the rack with the same cutout. And the first is to put on the mounting screws. Once we put the screws back on the mounting rack, we're going to rewiring the relay. And first I'm going to wiring the bottom CT-VT inputs, then the top output relays and the control power, then plug into the RTD terminals and the digital inputs, communication port, and analog outputs. So first I'm going to put in this Okay, now I finished the rewiring of the CT-VT at the bottom and the output relay and the control power on the top. I'm going to plug in the terminal blocks. First, I'm going to plug in the RTD terminal blocks. And then the digital inputs, the communications and analog outputs. Okay, so now this whole rewiring finished, and this process also applies to the 269 Plus. You just need to rewiring everything. And also pay attention to that the 269, that the ground CT has no 1 amp input. So now we can power up this rack. So now the whole rewiring of the 859 is done. So now I'm going to apply the power to the relay and see this relay is powering up. Okay, now the relay finished the booting. We can see this big LCD screen of the 859 with the single line diagram, parameters, and this replaced the old 369 or the 269, that is small LED display. 859 used the Anavista 8 Series setup software version 4.0, which also works for other 8 Series relays. To do a quick connect of the 859 with a front panel USB port, first plug in the USB cable to the front USB port, and then click Quick Connect button, and then click Connect, and then you will see this processing bar at the bottom. And now you see a message, device, quick connect, ended to the site, quick connect. And from the quick connect, we can open and check the hierarchy menu of the relay. So for example, the installation, we can set this from not ready to ready. And click Save. If the connection fails, then please refer to the troubleshoot PDF file saved under the Program Files GE Power Management 8 Series PC. To download the setting file of the 859, it's the same as the 369 software. Just right-click over the device. Here is a quick connect device in the online window, and then choose Read Device Setting. Then we can give this setting file a name, MCC_1, and click Receive. And then we can see this setting file be saved in this offline windows. So this is the offline Windows setting file. And there's two ways to write this setting file back into the relay. The first is the same as the 369. You just right-click mouse over the setting file, and you can choose this write setting file to the device. Then it will write into the relay, same as the 369. There's another way. This is only available for the 8 series platform, is drag and drop. So you can make some changes in the offline setting file and drag this setting file and put it over the device. Then here is a quick connect device. Then we can just click yes. Then the setting file will be right back into the relay. Okay, we got a message. Setting file successfully written to the relay. The user can create an offline setting file from scratch in the offline window just by right-click mouse and choose New Setting File. And from here, we can choose the 859 motor relays, and then you can choose different order code. You can choose the basic 369 or the advanced 869. So here, if I choose advanced, and then each options just to give you to choose the different functions. And for this, mostly just one options. It's a simplified one. And here you can choose the advanced features. And for the comms, you can choose the 61850. Advanced cybersecurity, and then click yes, and you can also give this a name. Okay, so we can rename that default untitled name to the MCC_2, and then click OK. So this way, you can create one offline setting file without having a relay. So now we have the second offline setting file, MCC_2. And lastly, we can also import 369 setting file. To import the 369 setting file, we can right-click mouse and choose and new setting file. So under the at the bottom, there's one checkbox: initiate setting file from 369 setting file. So check this box and click the three dots and go to find the setting file folder. And we got the 369 relay.369 setting file, and then click open. And then just click OK. It will do this automatic conversion of the 369 into 859 setting file. Okay, so now this finished the whole conversions. We can see that have a different colors. For the green, it stands for successfully converted, and for the amber color, you need a verification, and then you have the red color, need a manual configuration. So this is the setting you can check. Okay, so that's the conversion part. And last, for this setting file, it is using the default untitled name. If you want to rename to MCC_3, we can right-click mouse and choose rename setting file, and you can call this _3. Yeah, so now we have 3 offline setting files in the offline window. The local digital inputs in 369 are replaced by the contact inputs in the 859 with the default names. So for example, the external reset, emergency start, access switch, speed, differential, and spare, etc. To use this default name, the relevant setting need to be configured. For example, the set points, we need to go to the security, and configure this access points. For this case, we can choose the access point 3 and save. Another one example is the 52A speech contact. 52A is under the breaker, and this one we need first configure the switching device to be the breaker. So the switching device is also under the device motor. Set up and sets the switching device to be motor or the contactor. And then for the 52 switch, we can set this to as a spare. That's usually we do in the 369. And another example is the emergency restart. We can do this setting under the also the same setup of this motor, emergency restart. We can choose here and set to contact input 2. So that's all the digital inputs settings in the 859. They're called the contact inputs, and by still using the same default names in the 369. There are 4 Form C relays in 859, and each relay can be configured under the protection element. Or this can be configured under the output relays under outputs, and by default they're using the same name in the 369 trip alarm auxiliary 1 and 2. For the operate, you can choose that the flex operand list to assign an operand to this operate relay. And the types of the relay has these options from pickup to dropout, the while, pause, pickup, dropout, self reset, and latched. Depends on which the options you're choosing. Some settings will disappear or be added. For example, when you choose the pickup and dropout, you will have that the pickup values and drop values available for you to enter. And then when you're using the self reset and latched, that delay time will disappear. Okay, so this is the type, and under the options you have a fail-safe and non-fail-safe. Same like 369. The fail-safe relay operate when the coil is de-energized or the relay control power is lost. The waveform in 369 has only the trigger position setting, but in the 859 there's lots of settings under the transient record. So not only the trigger position, but we got the trigger mode and the trigger on and digital and analog inputs. So much more information we have here, and we got have a shortcut hotkeys to click. By clicking this COM tree, the record, we can see the waveform. And for this one, we got pre-triggered waveform, 3 waveform for the short circuit. We can click mouse and dragging this position to zoom in to see this waveform of this the 3-phase. The digital is the short circuit. And to see the events, we can click this first button, the event recorder, and we can see the events. And here we can see the 3 different colors, and by clicking choose the different colors, you can see the delta time of the different colors. And 859 can record a maximum 2048 events, which is more than the 512 events in the 369 and 1024 events in a regular 8 series relay. Under the motor setup, the nameplate's parameters can be entered here, like the FRA, service factor, rated voltage, etc. In this example, we're going to set the FRA from default 100 to 260 amps. And also the overload factor to 1, nameplate to 130, 200, and the horsepower will be 6700. The emergency restart, we left this to the default contact input to on, and this can be set into the other contacts just in case if you're using a different wiring. And for the acceleration time, we can set this to be 10 seconds. This is the default time. And this is just a little bit longer than the motor acceleration time in the datasheet. The VFD variable frequency drive is under the motor setup. This function must be enabled in order to ensure the proper performance of the 859 relay for the motor application with VFD. There are 2 typical VFD motor applications. First is motor starts and running through the VFD. The second one is motor starts through the VFD but running through the bypass switch. In motor applications where the VFD can be bypassed, status of the bypass need to be set under the bypass switch. And we can choose this bypass switch under the bypass switch setting. When the bypass switch is open, VFD bypassed operand is not asserted. Frequency will be calculated from the phase current A. Frequency element will be inhibited if the phase current is below 10% of the nominal. When the bypass switch is closed, VFD bypassed operand is asserted or the function is disabled. Then the frequency source is switched from the current to voltage. All protection elements and metering work as normal. VFD setting will also affect the settings of the current unbalance 46, and we'll cover this later in the 46 element. (859) thermal model is a main protection function. It consists of the 5 key elements: the thermal model curve, overload pickup level, unbalance biasing, motor cooling time constant, and RTD bias. For the detailed theory about the thermal model, please refer to the FMPR training modules 109 motor protections. The thermal model is saved under motor and of the group 1. So for these examples, we're going to set these parameters to the thermal model first. The trip function is set to trip, and also the time dial will keep the default 1, and also using the overload curve type to be motor. When the motor curve is selected, the trip time is calculated with this equation. 369 has the same equation with 859, but when converting 269 or 269 plus, pay attention to the curve numbers of the relay. For the curve 1 to 4, 269 series has the same timing with the 369 and 859, but not for the curves 5 to 8. For example, the curve 5 in 269 is close to the curve number 7 of the 369 and 859, and curve 6 of 269 is close to the curve 9 of 369 and 859. Curve 7 of 269 is close to the curve 12 of 369 and 859. And curve 8 of 269 is close to the curve 12 of 369 and 859. For the unbalance bias key factor, we can use this calculation of 230 divided by the log rotor current squared. So the value is 6.96, so we enter 7 here. For the hot and cold curve ratio, which is calculated by simply dividing the hot safe start time by the cold safe start time, this information can be extracted from the thermal model curve. From the motor thermal limits curve, we can determine that the hot safe start time is approximately 18 seconds and the cold safe start time is approximately 24 seconds. Therefore, the hot-cold curve ratio should be programmed as 0.75 in this example. The RTD bias will enable the temperature from the stator RTD sensors to be included in the calculation of the thermal capacity. This model determines the thermal capacity used based on the temperature of the stator and is a separate calculation from the overload thermal model for calculating the thermal capacity used. The minimum temperature is set to 40 Celsius, which is the ambient temperature. And the center point is set to the motor's hot running temperature is calculated with the temperature rise of the stator plus ambient temperature. The temperature rise of the stator is 80 degrees. Therefore, the RTD center temperature, we can set this to 120 Celsius. And RTD bias maximum set point set to the rating of the insulation or slightly less. For the class F insulation, it is used in this motor, which is rated at 155. Once min-max mid-temperature set, the corresponding TCU can be calculated with this equation, and the motor thermal capacity used will be displayed the higher values RTD and unbalanced current bias calculated by the TCU. But only the RTD bias will not make the relay trip. It must have that current level higher than the overload pickup. There's one RTD bias voting, and this will make sure that at least 2 RTDs has been configured as a stator type, and for the maximum stator RTD temperature will be used by the RTD bias feature only if both maximum stator RTD temperature and voting RTD temperature, which is the second maximum temperature, within the range defined by the set points RTD biasing voting band. Otherwise, RTD bias feature will be blocked automatically. The RTD voting band that specifies the temperature difference range between the maximum stator RTD temperature and another voting stator RTD temperature. The volt-dependent VD function that is used for the high inertia load, and we can just disable for this function in this example. In the unbalanced elements, we'll cover the current unbalance 46 and phase reversal 47 two elements. Unlike the calculation of the current unbalance in 369, which use the maximum deviation current from average current minus the average current divided by the average current of the FLA current. In 859 relay, the unbalance is defined as the ratio of negative sequence current to the positive sequence current with adjustment factor. When the VFD function is enabled, the measurement of sequence component I2 over I1 from the current phasor may not be accurate depends on the VFD output currents. Then, the lookup table method is used to calculate the unbalanced current value. In this example, we're going to set the trip delay to 25% with the time delay of the 10 seconds. And for the alarm function, we're going to set this to be 20% and 10 seconds delay. Phase reversal function 47 can detect the phase rotation of three-phase voltage. If the phase rotation of the three-phase voltage is not the same as phase rotation set under the system phase rotation, then reverse phase rotation alarm will occur after the delayed pickup. For the current mode set to no, the phase reversal detection alarm uses three-phase voltage only when the voltage are greater than the 50% of the VT. When the program is set to yes, currents are used to detect phase reversal when the voltage are less than 50% of the VT or the voltage are not available. Current-based method is only activated after the measured current are above 5% of the motor FLA. In this overcurrent element, we'll cover only the overcurrent elements under the motor settings: mechanical jam, overload alarm, short circuit, and ground fault. These are all the available overcurrent elements in the 859 basic auto code. If the 850 auto code is advanced, then there will be a new current elements group available to use. The mechanical jam setting should be set below the overload curve but above any normal overload conditions of the motor. The main purpose of this mechanical jam element is to protect the driven equipment due to jammed or broken equipment. The overload alarm is used to alarm abnormal load increases that can indicate problems with the process. An alarm is enabled only after the acceleration stage is complete and the motor has entered the running of the overload stage. Once enabled, the alarm is generated when the biased motor load current exceeds the pickup settings for the time delay specified by the setting pickup delay. The short circuit trip should be set above the maximum lock rotor current, but below the short circuit current of the fuses. To calculate the setting for the short circuit pickup, first multiply FLA 260 with the lock rotor current 575% to get a result of 1495 amps. Then this result is multiplied by 1.7 to raise the short circuit pickup above the theoretical asymmetrical points to a value of 2542 amps. Now convert these values to the per unit of the CT primary by dividing by 400 amps to give the result of 6.35. Therefore, we can enter this 6.4 times of the CT to this setting. The overreach filter functions removes the DC component from a symmetrical current present at the moment of the fault. This eliminates overreach, however, the response time slows slightly up to 15 milliseconds. For the interrupting device, when it's set to the contactor, it's not rated to break the short circuit fault current. And then this function should not be set to trip and instead should be set into alarm or latched alarm, and assign an auxiliary relay connected to an upstream device which is capable of breaking the fault current. The ground fault input can be from zero sequence CT or core band CT, which provides higher accuracy. When the ground CT type is set to 50 to 0.025, then the pickup range is from 0.25 to 25 amps. Another way to use the residual connection, if the cable are too large to fit through the zero sequence CT window or the trench is too narrow to fit the zero sequence CT, this configuration is inherently less sensitive than that of the zero sequence configuration. The slight mismatch of differential CTs combined with a relative large phase current magnitude produce a false ground current even when the three phases are balanced. So the pickup level should be set higher to disregard this error. When the motor starts, the starting current, typically 6 times FLA for an induction motor, has an asymmetrical or DC component. This momentary DC component causes a net current into the ground input of the delay. Undercurrent and underpower are used to detect the loss of load of the motor, for example, the loss of suction in a pump application or the broken belt in a conveyor application. The undercurrent element responds to a per-phase current. When the motor is in a running state, an alarm occurs if the magnitude of any phase current falls below the undercurrent alarm pickup level for the time specified by the undercurrent alarm delay. Furthermore, a trip occurs if the magnitude of any phase current falls below the undercurrent trip pickup level for the time specified by the undercurrent trip delay. The alarm and trip pickup levels must be set lower than the lowest motor loading during the normal operation. The underpower element responds to the total three-phase real power measured from the phase current and voltage. Underpower may be used to detect loss of load condition. The loss of load condition does not always cause significant loss of current. Power is a more accurate representation of loading and may be used for more sensitive detection of load loss or pump cavitation. In this session, we'll cover the loss of excitation 40 and reactive power 40Q. The loss of excitation protection is applied to protect synchronous machine from overspeeding, as well as to recover system from voltage collapse. Loss of excitation protection is achieved using the positive sequence impedance measurement from voltage and current, and two inverted offsets, Moore circles. In the case where the circle element is enabled and measured positive sequence impedance falls within this circle, the element operates with the corresponding time delay setting. For the equations of the calculation of the two Moore diameters and offset, please refer to the instruction manual. In a synchronous motor application, the reactive power element can be used to detect the excitation system malfunction, for example, under excitation, loss of excitation, etc. Once the three-phase total reactive power exceeds the positive or negative level for the specified delay, a trip or alarm occurs indicating a positive or negative kVAR conditions. VT fuse fail detection can be used to block this function. In this session, we are going to introduce the acceleration time and the start supervision. All these protections are used for the motor starting or the motor restarting. Acceleration time can detect the stalling during a start and trip the motor before the thermal module operates. This mode can be set to definite time or adaptive, two modes. When set to definite time, then the acceleration time set under the motor setup acceleration time. Here we set to 10 seconds. The datasheet has the acceleration time of the 9 seconds. When the mode set to adaptive, then the element uses the effective acceleration current to adapt the starting condition. Under the supervision, it has the single shot restart, thermal inhibit, maximum starting rate, maximum cold hot starting rate, time between starts, restart, delay, etc. For the single shot restart, it allows the motor to be restarted immediately after an overload. The thermal inhibit is provided to inhibit the starting of a motor if there is insufficient thermal capacity available for a successful start. Starts are inhibited when the thermal capacity is greater than the adjusted thermal capacity TCADJ subtracted from 100%. TCADJ is the thermal capacity required for a successful start. Maximum starting rate. This defines the configurable number of start attempts allowed in a programmable time interval. Maximum cold hot starting rate defines the settable number of cold and hot start attempts allowed in a programmable time interval. Time between starts. And this enforces a configurable minimum time duration between two successive start attempts. And the restart delay is used to ensure that a certain amount of time passes between the time a motor is stopped and restarting of that motor. In this session, we'll introduce the overspeed 12 and underspeed 14 elements and backspin detection. The contact input 4 is defaulted as a speed switch in 859, but any of the input contact can be used to read the pulses from the input source. The source of the pulses can be inductive proximity probe or Hall effect gear tooth sensor. The speed algorithm calculates the number of pulses in the window length and converts it into an RPM value. A minimum pulse width of 10% of a resolution is required to detect a pulse from the pulse source. The element can be set two modes, underspeed and overspeed, under the set points of the direction. The backspin detector enables 859 to detect motor freewheeling in reverse in downhole pump application. The backspin detection allows 859 to sense if motor is spinning after the primary power is removed. These inputs must be supplied by a separate VT mounted downstream on the motor side of the breaker or the contactor. The calculation of minimum frequency equals to the minimum speed multiplied by the numbers of the poles divided by 120. The 859 relay can monitor up to 12 RTDs and 12 RRTDs. In this session, we're going to introduce the RTD temperature, RTD trouble, and RRTD, the remote RTDs. 859 has the I/O cards installed in the relay can supply up to 12 RTDs. To enhance the accuracy of the RTDs, ensure all 3 cables are of the same length and gauge. In addition, the compensation and return wires must be connected to the RTD side and not on the relay side. Each RTD can be configured to have a trip temperature and an alarm temperature. The trip temperature is normally set at the insulation rating. The alarm temperature is normally set slightly above the normal running motor temperature. There are 4 types of the RTDs for the platinum, nickel, 120 ohms and 100 ohms, and 10 ohms the copper. The resistance of each type RTD can be converted into different temperature according to the conversion chart. For the application, there's settings for stator, bearing, ambient, and others. Only the application set to the stator that will be used for the RTD bias in the thermal model. And the trip voting will end it for the actual security in the event of RTD malfunction. Voting will select the second RTD to pass an AND gate with the first RTD. Both RTD temperature exceeds the trip setting, then trip will occur. The RTD settings can be easily copied into the other RTDs just by choosing the copy from and to and click copy button. Then we can see the settings are duplicated. When set to alarm or latched alarm, RTD trouble element monitoring all the RTDs that are either programmed as alarm or trip or configurable and generate alarm if any of the RTD are detected as open or shorted. Upon detection of an RTD open or shorted condition, the element also asserts the RTD trouble PKP and RTD trouble OP and operates the assigned output relay. Both RTD and RRTD can be monitored using this element. The RRTD modules has been designed to mount it closer to the motor to reduce the length of the RTD cables. The 859 can then monitor the RTD from remote location and use this temperature information for protection and metering purposes. Each remote RTD module supports the digital inputs of 6 inputs, and each one can be assigned to the general switch or the digital counter. And also supporting the 4 output relays. And for the application of the RTD, which can be set under the RTDS, and each application we can choose stator, bearing, ambient, and other. And this setting can be copied by clicking the copy button. It can be easily duplicated for the other RTDs. Now let's recap what we covered in this training module. First, in the hardware session, we introduced the front panel and the rear terminals. We know that the functions of the front panel push buttons and LEDs, and how to navigate the front panel menu. And for the rear side, we know that the 4 sides of the wiring, left and right sides, and therefore the RTDs, digital inputs, the communications, and analog outputs. They're the same as the 369. And we also demonstrated how to upgrade one 369 into 859 relay. The 169 and 269 plus upgrade is similar with the 369 upgrade. You just need to rewire all the connections. In the software configuration, we demoed how to do the quick connection with USB, and also how to read and write the setting files, how to convert 369 setting files into the 859 relay. In the thermal model, we introduced the thermal model theories like unbalance bias and RTD bias. Then in the unbalance elements 46, 47, we introduced the current unbalance calculations and phase reversal protection. In the overcurrent elements of the motors, we introduce the mechanical jam, overload, alarm, short circuit, and ground faults. So make sure when using the circuit breaker, make sure to use circuit breaker for the short circuit protection. Don't use the contactor. Then we introduce the undercurrent and underpower 37P. These two elements used to protect the loss of the load. Loss of excitation and reactive power 40 and 40Q. These elements, we introduce that loss of excitation that's used for the synchronous motor protection. In the acceleration time and start supervision, we covered different ways of protection during the motor starting and restarting. In the speed protection and backspin protection, we covered over speed and under speed. In the last RTD temperature and trouble session, we introduced a separate RTD protection, which is different with the RTD bias under the thermal model. These are some advanced topics are not covered in these 859 training modules, such like two-speed motor, out of step, electrical signature analysis, broken rotor bar, stator interterm fault, etc. For these topics, we're going to cover them in the 869 training modules. And that concludes these training modules of the 859. Thanks for watching.